Hi everyone, so welcome to another video. So this is one of the most important video that you can see in my channel, of course, because here we have the system power block diagram or the power sequence. And when we study the power sequence means we study one of the most important topic in motherboard repairing, because if you understand how power are divided and managed into the motherboard, you can of course figure out and troubleshoot and isolate the defect on the failure in any motherboard very quickly. Okay, so let's get started. But please, before diving into the course, make sure you subscribe, share the video and like the video, because your likes motivate me to create more and more unique videos for you. And of course, please join me in my Patreon page for more exclusive content. So let's get started. So we're gonna begin from the adapter. Do you see we have here the adapter or charger? Okay, from the adapter until we get these voltages, I'm going to teach you and to explain to you step by step how voltages are generated in the motherboard step by step. Okay, so let's begin from here. We have basically the adapter. Let's see first an overview about the power sequence, and after that going deeper and deeper. Okay, so we have the adapter over here. So this is the adapter. Okay, here we have the battery. Okay, and of course here we have the motherboard circuits. Okay, so here basically this is over here, as you can see, this is one part or one section where we have the adapter and the battery, and from here we have the motherboard. Okay, so let me remove this around. So this is the adapter and here we have the battery. Okay, so for the laptop it can be working using the adapter or the battery. So here basically this is the first channel, this is the first channel of power, and here we have the second channel for the power. So when the adapter is inserted, the 19 volt or the VN or the input voltage will goes in this side, as you can see, through this switch or MOSFET. Do you remember the switch? For next to every adapter or battery we have a switch, as you can see. Okay, we have a switch here, also we have a switch here, because this switch control the transfer of the voltage. Okay, let's make it easy for you. So let's remove this also. So let's begin from here. So we have the adapter. So once the adapter is inserted here, this one is not used, the battery is not used in this state when the adapter is inserted, so the battery is not used. Okay, so the voltage, the 19 volt, will go in this direction, and here we have the MOSFET. So this MOSFET should be controlled by the charge IC, okay, within the gate, and then the 19 volt will pass here and then goes here. Do you see this path? This path basically is for 19 volts. This path hold 19 volt. Okay, so the 19 volt will be applied to this first circuit, to all circuit in the motherboard. This is the first circuit, okay, to generate 3 volts here and 5 volts. Okay, and also the VN or the 19 volt will be applied to this circuit in order to generate 1.5 volt and 1.05 volt. Okay, this is basically for chipsets, and also will feed, as you can see, this IC in order to generate, as you can see here we have the VN, in order to generate the CPU core for the processor. So let's begin from the beginning. Okay, so we have the voltage here in this IC. Okay, so once this IC get the voltage, the Vn, okay, so this max 1999 will of course generate this voltage. So once this one receive the Vn from the adapter, it will generate the 3 volt always and also the 5 volt always. We called it always because these 2 voltages are always present in the motherboard. If you connect just the adapter, you will get these voltages, or also the battery, you will get these voltages without powering on the computer or the laptop. Okay, so this one, after receiving the Vin, it will generate these 2 voltages. So here please pay attention. Here you will understand the importance of 3 volt always and 5 volt always. If this voltages is missing, we will not get all these voltages. So all these voltages are based on this mother voltage. We called it the mother voltage because without this voltage, those will not be generated. Here also for 5 volt, without this voltage 5 volt always, we will not get these voltages, and also we will not get these voltages. Okay, means if we don't have the 3 volt PCU always, this voltage will be missing. This also, this, all these voltages will be missing. That's why we called these 2 voltages also main power rails, and always these voltages should be present. So in terms of troubleshooting and addressing the failures within the motherboard, as a technician or engineer, you should always pay attention to these 2 voltages if you want. So this is basically, now I'm going to teach you the right process to detect and troubleshoot the failure for within a motherboard. The first is to check the adapter. Is it good or not? Do you have 19 volt? So sorry, do you have 19 volt here? So let's remove this one also. So first, check the adapter, the state of the adapter. The adapter should be good adapter. You should get 19 volt in the plug of the adapter. Then you should check whether the 19 volt is passed from the adapter to this side, basically from the drain to source or from source to drain, depending on the type of MOSFET. Is it N-channel MOSFET or P-channel MOSFET? Please, you will find videos in my channel about what is channel MOSFET and what is N-channel and P-channel MOSFETs, and what is the difference between them, and the circuit diagram for each one. Okay, just you can go to home my channel, go to videos, and in the search box write P-channel MOSFET or N-channel MOSFET, or just write MOSFET and press OK, and you will get all videos about MOSFETs. Okay, because of course the MOSFET also, for any technician, you have to know about MOSFET, the MOSFET pinout, how to test the MOSFET, and anything, the MOSFET circuit diagram, the MOSFET references, how to replace a MOSFET if you get a bad MOSFET. For example, a bad MOSFET with a reference and you didn't find that reference, you should replace it with another reference. Okay, so how can you know if this MOSFET will be fitted to this MOSFET? What is the characteristics that you should revise and review in terms of temperature characteristics, humidity characteristics, voltage characteristics, current characteristics? I explain all this in my channel. just go and search for MOSFETs, how to test MOSFET, or MOSFET pinout, MOSFET circuit diagram. You will find all in my channel. And be sure please that if you follow me in this channel, I'm sure that you will be a very professional technician or engineer in hardware repairing. Okay, so let's continue. So you should check whether you have 19 volt here, and then check this side also. Did you get here 19 volt or not? If you didn't get 19 volt, means the switch could be the failed component, but you should also check the gate here. Check the gate. Does this MOSFET receive the control signal or not? Okay, then of course you can track the voltage until you find the 3 volt and 5 volt. If you didn't find this 3 volt, always stop here. Do not continue troubleshooting this. No, it's just waste of time to troubleshoot other voltage or signals here. No, you should go here in this side and look for the problem. It could be this IC, as you can see, the maximum 19. So the maximum 1999. So please, let's remove all these arrows. I use just these arrows to make the explanation easy. So if you didn't find 3 volt here, avoid to check here. Go and check where is the problem. Is it the maximum, means the control IC that generate this 3 volt always? Because this IC could receive the 19 volt and will not generate 3 volt. Why? Because there is other inputs rather than the VN. There is some inputs, for example, enable signals, there is some shutdown signals, boost signals, basically clock signals, etc. You should always check all inputs. Of course, not all inputs, but the main inputs. I have also videos in my channel about how to check inputs, especially for the charge circuit and the 3 volt 5 volt control circuit. So for any topic that you have in your mind, go and search and go to home page in my channel and video and search that topic. Okay, so let's assume that we get the 3 volt and 5 volt. Okay, let's assume that we get the 3 volt and 5 volt. So based on these two voltages, these also are circuits or controllers. Do you see? This voltage will be applied to this control, and this control will generate 3 volt S5 in state S5. Here, this MOSFET, as you see, should receive the 3 volt, as you can see here, should receive the 3 volt always, and also this important S5 on. This is enable signals. Without this enable signals, do you see here, for all these MOSFETs we have enable signals, as we have seen in previous videos. We have S5 on, we have this enable signals, we have another here for this MOSFET, we have the main D for this one, we have the SAS D for this one. So without this enable signals, even if this MOSFETs receive the 3 volt, they will not generate these voltages until they receive the enable or control signals. Okay, we call it control signals. Do you see? This is basically what you have to know about electronics, about maybe microelectronics, and how to troubleshoot circuits. So to summarize this part, within this part, for any circuit, it should please receive all inputs. Okay, it have to receive all inputs. Okay, after that it will generate output. If you didn't get output here, this doesn't mean this IC is bad. if you didn't get output, you should go back and check all inputs. You should check all inputs. Are the inputs generated or not? So this is basically the secret of troubleshooting and isolating integrated circuit defect or failures. Because many of technicians, if they didn't get here, for example, 3 volt, the problem is this one, is the IC. We should remove it. They remove the IC, the problem still persists. Why? Because the IC basically miss an input. This one, for example, here, for this IC, for example, so let me make it easy for you. For this IC, for example, this IC here, okay, this IC or MOSFET or controller, it generates plus 3 volts and plus 3 volt SAS. Here, as I told you before, 3 volt, but these two voltages are different in terms of current and in terms of control signals. So this IC generates this 3 volt after receiving this control signal, and generate this 3 volt after receiving this control signal. Okay, so without these two control signals, without, for example, if the IC receives this control signal and the 3 volt here, so this control signal at 3 volt, it will generate this voltage, but this one will not be generated. So here, what is the problem? Please think, what is the problem here? This IC generates this voltage and doesn't change this one. So the IC is bad? No, this is the problem. The IC is not bad. Let's go back and check the output. We have this one, okay, we have 3 volt, okay, this one is missing, means it's not the IC or the control. The problem is the enable or control signal is bad. Let's go back and check the source for this signal. Okay, so this is it, guys. I hope that you understand a little bit how to troubleshoot like this, like these issues. So let's go and continue. So this is for 3 volt. The same thing for 5 volt. Also, you see, the same thing for 5 volt, as you can see here. The same thing. Here we have switch. The switch will generate these 2 voltages after receiving the 5 volt, and this, the SAS control signals to generate 5 volt, and the main control signals to generate 5 volt. Okay, here. So please pay attention here. This is a very important section or channel here. This is basically the voltage for the RAM. Okay, this is the voltage for the RAM. So this voltages, to get the RAM voltages, we should first receive 5 volts. So this 5 volt will be applied to this IC Max 1992. So this IC will generate 1.8 volt, and based on this 1.8 volt, it will be applied to TPS, to another IC, to generate the RAM voltage terminal about 0.9 volt. Do you see? So here we have the main voltage for RAM, and here we have the secondary voltage or voltage for terminal. So this voltage, to get this voltage, we should get this voltage first, and to get this voltage we should get 5 volt, and to get 5 volt we should, of course, as you can see here, the 19 volt should be present. Let's summarize basically here. Here we have voltage for terminals about 0.9 volt. So if you didn't get this voltage, if you didn't get, for example, let's assume that the problem for this motherboard is this voltage. The voltage for RAM terminals is absent, about 0.9 volt. 9 volt. We should go and check. This IC could be the failed component. Okay, so because we don't have here the 0.9 volt, this IC could be the TPS 51100, could be the failed component, but you cannot see this is the failed component. You should go back and check the inputs. Is the 1.8 volt present here? Do you see here? We have 1.8 volt should be present here first, besides of these control signals. If you find that these two are present and you didn't get here the 0.9 volt, means this IC is the bad IC. But if you have, for example, let's assume that you have this voltage, the main on, and you didn't have here 1.8 volts, so you should go back and check this IC, because this is the responsible to generate 1.8 volt. So for this IC doesn't generate 1.8 volt. Is this IC the bad one? No, we should check. Is 5 volt applied to here isn't present? Is the SAS on present? If the SAS on and the 5 volt here are present, because this is inputs, and this IC doesn't change 1.8 volt, means the IC is bad. Let's assume, for example, that if one of these is missing, means the IC is not bad. Let's assume that, for example, we received the SAS on the control signal and we didn't receive 5 volts. So we should go back and check this IC, because this is the IC Max 1999. This is the responsible to generate 5 volts. So here we don't have 5 volts. So let's check the inputs. One of the most input for this IC is the VN. Is the VN present? Means 19 volt. No, for example, the VN is bad, is not present. So we should go back and check the switch. This is the switch. So let's check the switch. For example, here we didn't get 19 volt. The switch could be the failed component, but we should first check here the gate. Is the gate receive the control signals? If the gate received the control signals and we didn't get here 19 volt, means the switch is bad. If, for example, if the switch receive the gate signals and we didn't get here 19 volt, means we have problem with the adapter. So this is how you can troubleshoot the failure, basically. Okay, same here. This is also another IC to generate these two voltages. This IC, it receives the VN and then it will generate these two voltages. So these two ICs will also receive these two control signals to generate these two voltages. This switch also, or IC, will receive this control signal, and also this one will receive these control signals mainly to generate these two voltages. The same for the processor. As you can see, we have here basically the processor IC after receiving the VN, okay, because this is the VN part, and the VRAM, the control signal, and also this control signals. As you can see, it will generate the CPU core, and of course this power is the main power for the processor. Guys, this is a very important course video. Basically, I will continue is explain to you the power sequence tomorrow, but it's not this one. Another power sequence, another breakdown or detailed power sequence. Okay, another detailed, very detailed power sequence I will explain tomorrow in order to understand clearly and 100% about inputs and outputs. So thank you very much. Please don't forget to like the video, because your likes really motivate me to create more and more unique videos for you in a daily basis. And please subscribe, share the video with other people's interested like you, and join me in my Patreon page for other exclusive content, and if you want to download laptop schematics for free. Thank you very much, and see you tomorrow with another video.